Hello everyone, welcome back to System Shogun. Today I want to show you a methodology that I've been working on for the past few months. A methodology that came to life because of all the issues that I'm seeing as a solution architect when it comes to AI, vibe coding, and the technical debt that piles up with AI tools nowadays. So, what is this methodology trying to solve exactly? Well, currently, most of the folks who use AI are using it as an assistant. They're mostly vibe coding their solutions, their features, without taking the time to think about the solution itself, how it needs to work, and uh, that in the long run and even in the short run creates a huge amount of debt, and it makes the solution hard to maintain. In the long run, projects built like that will end up dead because very quickly those projects will become unmanageable because of vibe coding. And the issue with vibe coding is that usually people don't think when they prompt. They leave all the thinking, all the design decisions to the AI, and then they just sit and wait until the feature is built. They don't care how it's built though, it's just that it works. And this is a problem. There is no structure, there are no rules, so the AI decides how to build a solution based on its training, and it's a gamble. And especially if we're talking about a solution that is sold to customers, it's critical solution, it's something that has to be production ready. And this is going to be an issue for most of the companies these days because no one is training people how to use AI when they develop solutions. Everyone just reads how AI is writing all the code, but no one stops to think if that's actually the right way of doing it. And yeah, we're going to keep seeing issues like that. We're going to keep seeing projects die. We're going to see a lot of technical debt pile up, and we're going to see a lot of companies looking for experienced people who know how to build AI solutions using AI in the right way. So, based on my experience, I stopped and I started thinking about it, and I've been looking at the problem and where this problem is coming from, and how it can be solved basically. And that's how I ended up with this methodology that I call PAIN architecture, or protected AI native architecture, where the idea is that humans and AI work together because that's the future. But they work together in a harmony, in a ruled world where we have governance, where we have strict rules, and that way we build great solutions that are maintainable and that can outlive us. Let's start with the diagram that you're seeing right now. On the left side, we have the first phase, which is AI native architecture phase. In this phase, we have the architect and AI agents working together in a AI powered IDE, and we have the AI accelerated design phase where the architect and the agents plan, specify, and implement the architecture. The output is this here. So the output is architecture documents and specifications. Then, as you can see on the left side, by the way, the build order starts from the bottom. So we have the architecture documents and specification, and this comes from the discussions that we have with the business, figuring out the functional and non-functional requirements. And based on all that, based on all the discussions, we decide what type of architecture we are looking for. Is it like a monolith solution? Is it a microservices? Is it event-based? And all kinds of stuff. This is human endeavor, and it's based on the discussions with the business. And we write the specs. So how exactly this architecture should look like? Like I said, microservices, what types of services do we expect to have? Are we going to use CQRS? Are you going to use vertical slices, clean architecture? What types of modules do we have? Do we use a modular monolith solution? What types of services? AI Foundry, Postgres, SQL Server, whatever that is. And all that is based on the discussions with the business and based on the understanding of the solution that we have and the knowledge that we have as an architects of this solution. Once that's done, with the help of AI, we scaffold the architecture. And the AI works with the specs. That's the difference. We're not vibe coding anything. We write the specs, we explain the architecture, how it must be, how it must behave, and then rely on the agents to simply scaffold the solution, write the code. That's why people say that writing code is cheap now. But cheap doesn't mean efficient, doesn't mean quality. It just means that AI can write code fast. So once we have the architecture scaffolded, we go over to the tests. We build the tests again with the help of AI. And we build the guardrails. Usually those guardrails are again mostly markdown files, because the idea is that we will rely on AI in the development phase as well. So we need to have the guardrails that protect this architecture. Let's now quickly take a little bit detailed view into the AI native architecture phase and see what it looks like. So here is the architecture phase, and that's how it could look like, but of course it really depends on you and your solution. This is my interpretation. So we have the architecture docs and specs, which contain the architecture styles, patterns. Like I said, are we using event-driven architecture, vertical slices? Do we use CQRS? Do we use modular monoliths? You name it. These are the docs, and the specs cover all that. We have the architecture tests, which are libraries like ArcUnit, Net, for example. The documentation contains ADRs, guides, conventions, you name it, everything that will be useful to your teammates, and the feature documents. The architecture guardrails contain things like instructions, subagents, skills, hooks, prompts, and whatever else comes tomorrow. And of course, we have pull requests that contain the agent review and the human review. And that's basically it. Like I said, this is more of an art than a science. You need to find what works best for you, but the fundamentals are clear. Once we're done here, we have the second phase, which is the AI native development phase. And this phase is for humans and AI agents who work together in the AI accelerated development phase. And the output is both text and code. The text piece here is the feature documentation, feature specs, and these come before the code. Here again, like in the first phase, we need to write the specs before we write any code with AI. And that's the huge difference here. Here we specify what needs to happen. So if we're working on a sign in, sign up form, so here we explain that, for example, we are using Enter ID or we are using social logins like Gmail. We explain what type of form do we expect, how it should look like, what primary colors, what secondary colors, how the whole interaction happens. Are we using OIDC and OAuth2, or are we using key clock or something else, or whatever? We clearly explain what we want, and this gets version controlled. So tomorrow we can re-implement that by just saying to the AI, implement this specification for us. Unlike prompting a solution where the prompt simply disappears a week from now, we forget about it, we will never be able to find it again, and it's not maintainable. So once we have that, we ask the AI to implement the specification, and we get the feature code and the feature tests. All that based on the specification, not based on vibe coding and simply prompting. Of course, we as humans review the code, and once that's done, of course, we continue with the pull request, where we push the code. We have AI agents review the code first before any developer reviews the code. And once that's approved, the developer reviews the code as well. Then we have the continuous integration where we have the tests, code scans, whatever else you come up with. And at the end, we store the code inside the repository, which repository is now protected AI native code base, which is protected by guardrails, AI native by design, and governed by both AI and humans. And I know that this might seem abstract, so that's why I've created a quick solution to show you how a solution following this methodology might look like. And of course, this is not exact science, because at the end of the day, we rely on specs, we rely on text files, and you need to figure out what works best for you. But the idea here is that you build something that is maintainable and version controlled, and that's how you move forward with AI and building solutions around AI. It's not vibe coding. Let me show you what I have now. Here is the project that I have as a demo here. As you can see here, we have source folder, we have pizza API and pizza web. So the demo is about pizza. We're building a pizza shop. And in here, we have Claude MD file, which is the default file that Claude reads. And in here, I'm saying that it should read agents MD, which is also another standard file used by Codex and other solutions. So here's the agents MD. Here we provide some basic information that the AI needs to follow. And we start with the first one, which is all agents should follow in this order. First, it's the Constitution MD file. And if you are familiar with SpecKit, you know that they use the Constitution as well. Basically, this is the most important file that comes before any other file, any other prompt. This is the Constitution. Like in countries, the Constitution is above everything else. And here we provide some principles. For example, we are spec first, always. No feature is implemented without an approved spec, which is inside context specs. We use vertical slices first. Tests are mandatory unless explicitly waived per feature. We have dependency discipline, where we have the dependency file that needs to be followed. So agents cannot install dependencies without asking first. What else? So we have user-facing feature docs. So every feature needs to have a corresponding document file that explains this feature. we have definition of done here, which is the spec file. We need to follow the architecture document. Use only approved dependencies. So if this is a backend feature, follow the backend MD file. If it's a front-end MD file. Write tests and ship short user-facing feature document inside the docs folder explaining the feature. Okay, that's the constitution. We have backend document that explains the backend architecture. We're using vertical slices. We're providing a code structure example for the AI to follow. We give some guidance. For example, use minimal API, vertical slices architecture, proper error handling. This is the front end. We explain that is Blazor web app. We provide the code structure and some details here. What else? We have the specs document that explains the spec-driven development here. The system architecture, really simple. We have a tests file that explains the tests, how they need to look like. We have our design system here. Basically, it has some primary colors and some secondary colors, and that's how we enforce the design of our system by following this file. What else do we have? We have the dependencies MD, where we have the approved dependencies. So unless an AI really has a reason to add another dependencies, we are using only these. And if there is a need for a new one, we add it here. That's how we enforce strict monitoring over our dependencies and the good governance overall. So here are the specs. So we start with a template file that every spec needs to follow. And it basically shows how a spec should look like. Let me show you a spec and how it looks like. For example, get pizza catalog. Here you can see it's approved, and unless a spec is approved, it cannot go forward with the actual implementation. And that's how I did this. And if I prompt the agent to write me a solution, and if this is in draft mode, it will strictly say that we need to approve this first, unless we want to YOLO it. You know, you only live once, but that's just a joke. Okay, so that's the get pizza catalog. We have the contracts here. We have acceptance criteria, and this allows us tomorrow to re-implement this feature easily because we have it documented. It's not vibe coded. It's not a prompt that is long gone. This is version controlled. It's way more robust than just prompting and vibe coding. And this is lives with your solution always. And we have the docs. This is primarily for humans. So if you're not sure what a feature does, you go here, read it, and done. You understand it. Most of the times, in every project I've been, people are not documenting anything, and this is a huge problem because tomorrow teams change, or a year from now teams change, or even you forget what this does. And without documents, it becomes a nightmare, and you spend weeks figuring it out again. So double the work. Okay, I think that's basically it. Maybe we can implement a feature so you can see the flow. But before we do that, let me show you the solution so far, and keep in mind that it was built using this pain methodology. And in here, under Cloud folder, we have our agents, the backend developer agent and the front-end developer agent that we're going to be using throughout this solution. Let's take a quick look. So the backend developer, it's an expert in C#, .NET programming, focusing on best practices, yada yada. It has read, edit, bash, web search, and web fetch tools, and it's using Opus. We provide some context and some understanding for it, like to understand the constitution, the dependencies, the specs, the architecture. And we add the rules and the guardrails here. Same with the front-end agent, and that's our agent, and that's what we're going to be using to build the solution using this methodology. So there was no vibe coding. Let me show it to you. And here it is. I can sign out and now I can sign in again. And you see it is following the design patterns or design system rather that I've provided here. So it's not inventing any colors on its own. It's following the colors that we have, the design system that we have, the fonts that we have. Okay, let's sign in. And here is the solution so far. So we have 3 pizzas. Again, you can see that the colors are the same as in the login form. And we can see the details of a given pizza. And we can go back. That's basically it for now. And now we can implement a new feature to see the whole flow in action. And what I'm thinking is that we can implement the add to cart feature for a given pizza. And we just add it to the cart. Only front-end implementation. But that's enough to give you an idea of how things work. So let's see. We go back to Visual Studio. And before we do that, let me show you my Claude. And we'll say to our front-end agent, add a cart functionality under each pizza. Once the user clicks on it, it adds it to the cart. The cart is visible at the top right corner next to the user info. Let's see that in action now. As you can see, it starts reading the context. It will read all the markdown files. It will read the constitution, and it will know the rules. It will read the specs, as you can see. And now we're blocked because we need to have a specification for this feature first. And here the AI suggests that it drafts the spec for us, or we just YOLO without a spec, like I said. Let's draft a cart spec, and it drafts the spec for us by reading the template file first. And here is the markdown file that's being written. As you can see, it's in draft mode. So here we, as humans, need to review all this. So honestly, I'm not reading this now, but in a real solution, you need to go over all this, maybe make some changes. I'll skip that step for the sake of time, and I'll say here that this is now approved. And now I can say approved. And now it should start implementing this solution. Okay, and after 5 minutes or so, our feature is implemented. And here are all the changes that we did. So we have the components and we have the tests. So let's see if the tests are passing. So these are the API tests and these are the web tests. Let's run the tests again. And they did. Now let's run the solution and see what we have. Let's go back to home. And here's the add to cart. As you can see, again, it's using the same design system colors. It's not inventing any colors, which is great. Let's click add to cart. And here it is. We can add more. And that's basically it, guys.